Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss Workbook Lesson 2.3 Expressions and Indices. So let's start with the first question here. It says to you, match each rectangular card with the correct oval card. So let's just simply answer each rectangular card. Here we agreed in multiplication if the bases are the same, we're going to add the indices. So this is x to the power of 6. And here it's x to the power of 8. Here it is x to the power of 9, x to the power of 3. So you can just match this way. Here they request from you to match, so just match, which is going to be done this way exactly. Matching is a little bit confusing, the lines and where they're going, but you got the final answer anyway. Question 2, match also, but x to the power of 4 divided by x to the power of 2 minus the indices, so it is x to the power of 2. I'm going to just write over here. Here is going to be x to the power of 3. Here is x to the power of 6. And this is x to the power of 8. Just subtracting the indices. Two of these statements are true. Write true or false for each statement. If the statement is false, write the correct answer. So this is y to the power of 6. It is true. Y, I added the indices. Here, this is y to the power of 5, 6 minus 1. And don't say this is y to the power of nothing. No, it's not nothing. It is y to the power of 1. So 6 minus 1 is 5. Y to the power of 9. Okay, what they did here is that they multiplied the 5 by 4, which is wrong. Y, it's supposed to be y to the power of 9. 5 plus 4 is 9. Here is y to the power of 6. Not 9 divided by 3 is 3. No, it is 9 minus 3 is supposed to be 6, not 3. Here is g to the power of 4 all to the power of 2. We just say 4 times 2, which is 8. And this one 6 times 5, which is 30. 2 times 10, which is 20. And this one is 3 times 7, which is 21. The one over here, just to simplifying 6 y to the power of 4 minus 2 y to the power of 4 is 4 y to the power of 4. The indices do not change at all in addition and subtraction. Addition, subtraction. If the variables are the same, just and with the same power as well, so y to the power of 4. And here y to the power of 4, just minus the coefficients normally. 6 minus 2 is 4. Y to the power of 4 remains the same. Just like what they did over here, 3 plus 5 is 8, x to the power of 2 stays the same. Here, 7 and 9 is 16, x to the power of 3 stays the same. 12 minus 1 is 11, y to the power of 6 stays the same. Next one, I'm going to just answer them quickly. Multiplication, we're going to add the powers in multiplication. So this, a to the power of 7, b to the power of 10, c to the power of 8, in division, we minus the powers. So d to the power of 4, e to the power of 4, f to the power of 7. Here, two powers, multiply them. So g to the power of 8 times 4, 32, y to the power of 14, I to the power of 72. Here, adding and subtracting, and the variables have the same power, no problem. Just add the coefficients. So 13 j to the power of 2. Here is k to the power of 3. Here is 5 minus 8. 4 plus 1 is 5. 5 minus 8 is negative 3. L to the power of 5 stays the same. This one here, simplify. 3 times 2 is 6. 8 to the power of 2 times 8 to the power of 2 is 8 to the power of 4. 4 times 4 is 16. 16. B to the power of 7. Add the indices. Here, 6 times 6 is 36. C to the power of 12. 10 times 1 is 10. E to the power of 11. Here, division. 16 divided by 2 is 8. G to the power of 8. 12 minus 4. 9 divided by 3 is 3, h to the power of 6. 10 divided by 2 is 5, x to the power of 8. 5 divided by 1 is 5, x to the power of 4. So we just divide the coefficients and the indices, you minus them. 5 minus 1 is 4. Simplify, 3 times 4 is 12, a to the power of 5. So it's going to be this one. Add the indices. 4 times 5 is 20, b to the power of 4. Add the indices. This is 3, this is 1. It's not nothing. So 20 b to the power of 4. 15 divided by 5 is 3, so definitely this or this. C to the power of 6 divided by c to the power of 3 is c to the power of 3. We minus the indices. So 3 to the power, c to the power of 3 here. Simplify. 9 divided by 3 is 3. D to the power of 4. 5 minus 1 is 4. So 3d to the power of 4 is here. Question 9. Simplify the expressions and then sort the cards into two groups. Explain how you decided to sort the groups, which card does not fit. So let's do this here. This is going to be 3x to the power of 9. And here you're going to say 9x to the power of 3. And here you're going to find 6x to the power of 6. And here you're going to find 3x to the power of 9. This is 3x to the power of 6. Here is going to be 6x to the power of 9. And here is going to become 6x to the power of 6. Good. Now I found the answer to them. Simplify the expressions. Done. Sort the cards into two groups. So let's name the groups, whatever you're going to name them. So I have here group, let's say 1, and group 2. Group 1, I would put here this card. So I'm going to put this in group 1. Why? It has power of 9. 1. Why? It has power of 9. 1. It has power of 9. Here, 2 to the power of 6. 2. Group 2 to the because it's to the power of 6. Group 2 because it's to the power of 6. So I sorted them into two groups. And the two groups are based on the power. So this is to the power of 9, the power of 9, the power of 9. So I put them together, these three cards. The other three cards over here, they are in the other group because they are to the power of 6. Which one does not fit in any group? This card. Why? Because it's to the power of 3. It's neither to the power of 9 nor to the power of 6. Other students might choose to depend on the coefficient. Mister, I'm going to put this with this with also with this. Why? Because they have coefficient of 3. And the others, this with this with this, because they have coefficient of 6. No problem at all. Still, the one that doesn't fit is this one, because it has coefficient of 9, not 3, not 6. So both are correct if you're going to sort them based on the power, the index, or based on the coefficient, both are correct. Sophia and Zara, simplify the expression this, read what they say. I think the answer is 4x to the power of 5. I think the answer is 4x to the power of 6. Who is correct? Sophia or Zara, explain why. Well, we agreed if they are in brackets this way, and I want to simplify it, we mean here that everything inside the brackets is to the power of 2. So this is 2 to the power of 2, which is 4. X to the power of 3, all to the power of 2, as if you're saying this. Oh yeah, mister, we multiply the powers, so it's x to the power of 6. So it is this one. Okay? Explain why you just do it this way. You say because x to the power of 3, all to the power of 2, because x to the power of 3, all to the power of 2 is equal to x to the power of 6, not x to the power of 5. We multiply the indices, not add them. Good. Next, simplify. Simplify these expressions. It's going to be a mustard 3 squared, which is 9, x to the power of 14. 4 cubed is going to become 64, y to the power of 27. 2 to the power of 5 is going to become what? Is going to become 32, z to the power of 15. 3 times 5, 15. Next one, simplify. You're going to find this divided by 3. Simplify the coefficients first. The 3 over 12 simplified, divided by 3 is 1, yeah, mister? Divided by 3 is 4. You have 1 over 4. But 1 over 4 and 9, x to the power of 9 over x to the power of 3 minus the indices, x to the power of 6. You have a quarter x to the power of 6, or you can say x to the power of 6 over 4. order x to the power of 6 is here. This one divided by 3 is 1 over 5. Y to the power of 2 minus the indices 1 over 5 y to the power of 2. 30 and 25 divided by 5 is 6, divided by 5 is 5. So it is 6 over 5 z to the power of 5 minus 10 minus 5 is 5. But 6 over 5 z to the power of 5, which is this one. Divided by 2. Divided by 2 will give you 5 over 2. W to the power of 8 divided by W to the power of 8, it's just bye-bye. They cancel each other. W to the power of 0, which is just 1, which is just cancel each other. So it's 5 over 2. 5 over 2. Where is it? It is not there, mister. Definitely we said no W in the question, so this is not there. No W in the question, so this should not be there. 5 over 2. This is not 5 over 2. This is the only correct one. They converted it into a mixed number. How? The denominators stay the same. How many 2s are in 5? There are 2 2s in 5, remainder 1, so it is 2.5. Next, 4 to the power of negative 4 is saying to you it is the same as 1 over 4 to the power of 4. So 5 to the power of negative 3 is the same as 1 over 5 to the power of 3. 8 to the power of negative 5 is the same as 1 over 8 to the power of 5. 1 over z to the power of 1, which is just 1 over z. 1 over y to the power of 7. 1 over x to the power of 4. So if you flip it, this changes the sign of that index. If it was positive, we would have written it here negative. If it was negative, we write it here positive. Good. So here, x to the power of 5 over x to the power of 8 is the same as x to the power of 5 minus 8. Yes. We minus the indices, which is the same as x to the power of negative 3. Yes. Or 1 over x to the power of 3. Correct. Here is y over y to the power of negative 4, because 3 minus 7 is negative 4. But they want the answer to be written as what? As a fraction. So it's going to be 1 over y to the power of 4. M to the power of negative 8, but as a fraction, 1 over m to the power of 8. N to the power of negative 5, which is as a fraction, 1 over n to the power of 5. Here, match each rectangular card with the correct oval card. Let's do it. Dividing it by 5, dividing by 5, it will be 2. So as if you're saying here, literally as if you're saying it's 10 y to the power of 4 over 15 y to the power of 8. Divided by 5 is 2. Divided by 5 is 3. Y to the power of 4 over y to the power of 8 is y to the power of negative 4. So 2 over 3 y to the power of negative 4. 2 over 3 y to the power of negative 4. Where's 2 over 3? I found them. So 2 over 3 y to the power of 4. Yes. Didn't we say that if we flip it, if we get y to the power of negative 4 down the denominator, it would be positive? Yes. So 2 over 3y to the power of negative 4 is the same as 2 over 3y to the power of 4. I got the y to the power of negative 4 down. I changed the sign. So this is the same as this. So this is v. Next one. 12 over 16, mister, if you simplify it, divided by 4, it will be 3 over 4. But y to the power of negative 4, or 3 over 4, y to the power of, I'm going to take it down, and instead of negative 4, it will be y to the power of positive 4. So 3 over 4, y to the power of positive 4, this one. So this is triple I. And so on with the rest. Okay? Here, write an expression that simplifies to give an expression on this card. Here in B, you're gonna find one card that is left. I cannot actually remember which card. They just want you to write an expression like these cards that when you simplify them, they will give you the answer. So one of these oval cards will be left at the end unused. They want you to write one like the rectangular cards that simplifies to the oval card. Question 15. They want you here to show that this expression simplifies to this. No problem. Let's do it, but I'm going to do it down there, okay? So let's just say here, this is for question 15. We will erase it then and answer question 16. Show that this expression, 2n squared times this over that, will simplify to this. So let's simplify it. What is 2 times 3? 6, mister. Okay, get. Good. What is get? All right, so n squared times n to the power 5 is n to the power of 7. Perfect. Over 2 to the power of 3. Notice that everything inside the brackets is to the power of 3, is cubed. So 2 cubed is 8. N to the power of 2 to the power of 3 is n to the power of 6. Now let's simplify. 6 over 8 divided by 2 divided by 2, I'm going to by 3 over 4. N to the power of 7 divided by n to the power of 6 is just n. Oh, look at that. It is exactly the same. Mister, I can write it this way, or the n is in the numerator. You can also write it this way, 3n over 4. Both of them are the same. So 3 over 4n is the same as 3n over 4. They are the same. Good. The last question here. So now this way I showed that when I simplify this, it gave me the same. Question 16. It's not the last, actually. Let's do it. Here, they want you to show that this and this simplify to give the same expression. Show you're working. So just multiply 6 by 3 by 2, which is going to give you exactly 36. X to the power of 2, x to the power of 6, x to the power of 9 is going to give you exactly 9 and 6 is 15 and 2 is 17. Add the indices. So 2 plus 6 is 8 plus 9 is 17 over 4 x to the power of 13. What is 36 divided by 4? 9. What is x to the power of 17 over x to the power of 13? X to the power of 4. That simplified to this. If I do this one here, let's see if it will give me the same or not. 3 all to the power of 4. Mister, that's going to give me 81. X to the power of 4 all to the power of 4. It's x to the power of 16. We multiply the indices. 3 times 1 times 3 is just 9. X times x squared times x to the power of 9. Add the indices. It is 1 plus 2 is 3 plus 9 is 12. X to the power of 12. 81 divided by 9 is 9. X to the power of 16 over x to the power of 12. X to the power of 4. Okay, so when I simplified this one, it showed me that it can be simplified to 9x to the power of 4. When I simplified this one, it got simplified also to 9x to the power of 4. Now this way, I showed them that both expressions are simplified to give the same value exactly, or the same final expression at the end. Oh, we're done. Okay, so that's it. Thank you so much, everyone, and see you in another video.